Ever get that itch to understand how the tech world ticks? Maybe even learn to speak its language, starting with something accessible like Python. But then you stumble upon, the sheer volume of tutorials and feel like you're staring at Mount Everest.
Oh, yeah, it can definitely feel overwhelming.
I know that feeling. That's precisely what we're digging into in this deep dive.
And a really smart starting point, and what we're leveraging here is this fantastic, completely free Python course on YouTube. Think of this as your curated roadmap, sort of highlighting the essential landmarks on that journey.
Right, we're skipping the exhaustive trek through every single detail.
Exactly.
We've sifted through the materials from this freecodecamp.org tutorial, which covers everything from setting up your coding playground to crafting basic interactive programs. Our mission today is to extract the absolute must-knows, the core building blocks of Python, without getting lost in the weeds.
Sounds good. Let's do it.
Okay, let's unpack this. The very first step is getting Python onto your computer.
Absolutely. First things first. The tutorial rightly directs you to python.org downloads. Pretty straightforward.
Okay.
Now you'll see mentions of Python 2 and Python 3. It's important to know that, well, Python 2 still exists out there, but the vast majority of current work, and certainly this tutorial, focuses on Python 3.
So Python 3 is the one we want.
Yeah, that's the version you'll want to download and install. Think of it like choosing the current model of a car versus an older one both get you there, but the newer one has the features you'll likely need.
Got it. So python.org downloads aim for Python 3. Once that's downloaded, where do we actually begin writing this Python code? The tutorial mentions a basic text editor like Notepad, but strongly suggests something more tailored. Is it really that different?
It's a significant step up, yeah. This is where integrated development environments, or IDEs, come in.
IDEs, right.
Imagine a workshop designed specifically for, say, woodworking. It has all your tools organized, helps you spot mistakes early, maybe even has clamps to hold things while you work. That's kind of what an IDE offers for coding.
Okay, a specialized workshop. And the tutorial shines a spotlight on PyCharm from JetBrains.
That's a very popular one, yes.
They even point out there's a professional version you pay for and a community edition which is free and open source. And the tutorial uses the community version, so no cost to get started.
Which is great.
Are there any key advantages to using PyCharm Community right off the bat?
Well, what's immediately helpful is that the free community edition provides everything a beginner needs. You get a place to write code with helpful syntax highlighting.
So, like, different words, different colors.
Exactly. Keywords, commands, strings, they stand out. It also helps with error detection, catching typos maybe, and gives you an easy way to run your programs right there.
Okay.
The tutorial even guides you through that initial setup, like creating a new project.
Right. It's not just like opening a blank document. You create a project which helps keep all the related files together for whatever you're building.
Mm-hmm. Good organization from the start.
And then within PyCharm, you right-click on your project folder, go to New, and select Python file. Give it a name. The tutorial suggests something like app.py, and boom, you've got a clean slate to write your first Python instruction.
Your blank canvas.
So what does that first instruction typically look like? What's the hello world of Python?
It's elegantly simple. The print function, you just type print hello world inside those parentheses with quotes around the text. That's it.
And that tells the computer.
It instructs the computer to display those words, hello world, on the screen when you run the file. It might seem basic, but that's the core action. Writing and executing a Python command. It's your first, conversation with the machine.
Okay, print hello world. Got it. Now here's where it gets really interesting, I think. The tutorial emphasizes that Python reads and executes your code sequentially, one line after another.
Top to bottom, the order matters immensely.
Now, they use this cool example of printing out a little triangle shape, mated characters, right?
Yeah, exactly. Just a few print statements, each printing a line of the triangle. But if you simply rearrange the order of those print statements...
The shape changes completely.
Yeah, it's a visual and immediate way to grasp that the computer meticulously follows your instructions in the precise order you give them. Think of it like a recipe. You add the flour before the eggs for a reason. Same idea.
Makes sense. Okay, so we can tell the computer to display text. That's a start. But what if we want to work with information that might change as our program runs? That's where variables come in, right?
Precisely.
The tutorial uses this relatable scenario of a story where a character's name and age might need to be updated.
Yeah, and it highlights how cumbersome it would be to manually search and replace George with John or update the age 35 to 50 in 10 different places in your code.
Ugh, yeah, that sounds tedious.
Variables offer an elegant solution. They act as labeled containers, specifically designed for storing information.
So how do you make one? To introduce a variable in Python, you give it a descriptive name, like character name, and then mention using underscores for spaces.
Yeah, that's the common convention, like character name instead of character name. Makes it easier for Python to read. Then you use the equals sign to assign it a value, for example, character name George.
So what's happening under the hood when we do that?
Think of it as putting a label on a box. The label is the variable name, character name, and what's inside the box is the value, George. The computer reserves a little space in its memory, associates that space with the label character name, and stores the value George there.
Okay, a labeled box in memory. And once we have this variable, we can use it within our print commands.
Yep. The tutorial shows you need to end your text string inside the print, use a plus sign, plus, which acts like glue here, sticking your text string together with the current value stored in the variable.
So it pulls whatever's currently in the box.
Exactly. And if you're dealing with numbers, you might need to explicitly convert them to text first using straights.
Why is that conversion necessary again? Why can't it just stick a number next to text?
Python needs to know how to handle different tiles of data. When you try to add a string of text, like age, and a number, like 35, directly with just a plus sign, it gets confused. Is it trying to do math or just join them?
Oh, okay.
By converting the number to a string using 35, you make it clear. Treat this number like text for now, just stick it onto the end of the other text.
Got it. The real aha moment, for me anyway, came when they showed changing the value of character name at the very beginning of the code.
Right, like changing character name George to character name Tom.
Yeah, and instantly, everywhere that variable character name was used later in the story, it printed Tom instead of George. Change it once, updates everywhere.
That's the power of variables. It's incredibly efficient.
It's like magic, but it's just efficient coding, and you can even reassign new values later on, like change the name from Tom to Mike halfway through the program.
Absolutely. You just write character name Mike later in the code. It updates the value in that same labeled box. The old value, Tom, is replaced.
Cool. So this leads us nicely to the idea that the information stored in these variables comes in different types, as you mentioned.
Exactly. The tutorial introduces two fundamental data types right away, strings and numbers.
Strings are pretty intuitive. They're just sequences of characters, plain text enclosed in quotation marks, like George or hello there.
Yep. Names, sentences, any kind of text.
And numbers. You can store them directly without any quotes.
Right. Things like 35 or 70.5, which is a decimal number. Python calls those floats. Or even negative numbers like -10. No quotes needed for numbers.
Okay, strings and numbers. But strings aren't just static words, are they? Python lets you manipulate them.
Yeah, using built-in tools called functions, or more specifically, methods when they're attached to an object like a string. The tutorial shows you access these using a dot after the variable name, then the function name.
Right, like if you have a variable phrase Giraffe Academy, you could use phrase.lower.
And that would give you back Giraffe Academy, all lowercase.
Or phrase.upper for all uppercase.
Giraffe Academy, exactly. There's also I-supper, which acts like a question.
Like, is this string currently all uppercase?
Precisely. It returns true or false, Boolean values. And replace is super useful.
For swapping parts of a string.
Yeah, like phrase.replace, giraffe, elephant, would give you Elephant Academy. It's like a built-in find and replace just for that specific string.
That seems really handy.
Yeah.
Okay, shifting focus to numbers. The tutorial shows you can use them directly in calculations.
Yep. Addition plus subtraction, multiplication, division. They work just like you'd expect on a calculator.
2 plus 2 gives you 4.
Simple as that. It also introduces the modulus operator, the percent sign.
Right. That gives you the remainder after division.
Exactly. 10% 3 would give you 1, because 10 divided by 3 is 3 with a remainder of 1.
When might you use that?
Oh, it's handy for things like checking if a number is even or odd. If a number %2 equals 0, it's even.
Ah, clever. And you can store numbers in variables too, obviously.
Of course. Minum equals 5. Then you can use minum in calculations. The key takeaway again, though, is if you want to print a number alongside text.
You need that string function to convert the number to a string first.
Yeah.
Print. My favorite number is unplus string minum.
Exactly right, to avoid that type confusion for Python.
Okay. Beyond basic math, Python offers more tools.
Yeah, a collection of more advanced math functions, abs, gives you the absolute value, makes negative numbers positive.
So abs5 is 5?
Yep. Pow base exponent lets you raise a number to a power, like pow 32 is 3 squared, which is 9.
Okay.
Max num1 num2 finds the bigger number, min num1 num2 finds the smaller one, and round does what it sounds like, rounds a number to the nearest whole integer.
Pretty straightforward. They also give a sneak peek at the math module.
Right. They mention functions like floor for always rounding down, ceil for always rounding up, and squirt for finding the square root.
But you need to do something special to use those.
Yeah, you need to import the math module first, basically telling Python, hey, I want to use the tools from the math toolkit. They explain import in more detail later, but it's like needing to grab a specific set of tools from the workshop shelf before you can use them.
Got it. Import the tools. Now, programs don't have to be just one-sided conversations, right? They can get information from the user.
Absolutely. And the input function is the key to that interaction.
How does that work?
When Python hits an input function in your code, it pauses execution, displays a message you put inside the parentheses, like a prompt, enter your name, and then it just waits.
Waits for the user to type something.
Exactly. Whatever the user types up until they press enter is captured by the program. And crucially, it's captured as a string.
Always a string, even if they type numbers.
Always a string. That's super important. They show a simple example. Name, input. Enter your name, and then print hello plus name.
So it takes the input, stores it in the name variable, and then uses it in the greeting. Cool. You can use it multiple times too.
Sure. Ask for name, then ask for age, store them in different variables.
Okay. Building on this interactive capability, the tutorial guides you through creating a very basic calculator. This is where that input is always a string thing really matters, isn't it?
It really hits home here, yes. Because you ask the user for 2 numbers.
Using input.
Right. But you get back 2 strings. You can't just add the string 5 and the string 3 together and expect to get the number 8.
What do you get if you add 5 plus 3?
You get the string 53. It just sticks them together like text.
Concatenation again. Okay, so to do actual math.
You need to convert those input strings into numbers. The tutorial introduces int to convert to an integer, a whole number, and float to convert to a floating point number, one with decimals.
So you do something like num1, float input, enter first number.
Exactly. That takes the string input, converts it to a number that can have decimals, and stores that in num1. Then you can use num1 in calculations.
They also mentioned a potential value error.
Yeah, what if the user types cat when you ask for a number and you try to use int or float on cat?
Python wouldn't like that.
Nope. It would raise a value error. We'll see how to handle errors like that later with try except. But it's good to be aware that conversion can fail if the input isn't what you expect.
Makes sense. And this calculator example also introduces decision-making in code, right? Using if, elif, and else.
Beautifully, yes. This is the core of how programs can react differently based on conditions. You get the numbers, you get the operator the user wants to use, plus 8.
Which is also input as a string.
Also string. Then you use if statements, if operator plus e, then do the addition, elif operator elif, then do the subtraction, and so on.
Elif is short for else if.
Correct. It lets you check another condition if the previous if or elif was false. And finally, you can have an else at the end.
For anything else.
Right. If the operator was an L plus elif or elifec, the else block runs, maybe printing an invalid operator message. It's a really clear way to see how code can branch based on input.
Okay, if, elif, else. Control the flow. To really hammer these basics home, they use a Mad Libs game example.
Which is a fun one. It reinforces getting multiple inputs and then using them.
You just create variables to hold the user's words. Color, input, enter a color. Plural noun, input, enter a plural noun. Celebrity, enter a celebrity. Stuff like that.
Right, gathering the pieces.
And then you use print statements to tell the story, plugging those variables in at the right spots.
Yep.
Print, roses are purplish color.
Print, plural noun plus I or blue.
Print, I love wire plus celebrity.
Yeah.
Simple, but effective at showing strings and variables working together.
It ties those concepts together nicely.
Now, sometimes you need to store more than just 1 or 2 pieces of related information. What if you have a whole group of things?
That's where lists come in. The tutorial introduces lists as ordered collections. They let you store multiple values, often related, inside a single variable.
How do you make one? Square brackets.
Yep, square brackets. And you separate the items inside with commas, like friends, Kevin, Karen, Jim, Oscar.
Okay, a list named friends. What's crucial is how you get things out of the list, right? The index.
Exactly. Each item has a position, its index, and Python starts counting from 0. This trips up beginners sometimes.
So friends is Kevin, the first item.
Friends 1 is Karen, friends 2 is Jim, and so on. Zero-based indexing.
They also mentioned negative indexing.
Yeah, that's handy. Friends 1 always gives you the last item in the list. Friends 2 the second to last, working backwards from the end.
And slicing, grabbing a range.
Right. You use a colon. Friends 1.3 gives you a new, smaller list containing items starting at index 1 up to but not including index 3.
So friends 1.3 would be Karen, Jim.
Correct. Index 1, Karen, and index 2, it stops before index 3.
Got it. And unlike some other things we'll see, lists of mutable, you can change them.
Yes, that's a key feature. You can update an item by referring to its index. Friends 1 equals Mike. Now the list would be Kevin, Mike, Jim, Oscar. Karen's gone, replaced by Mike.
Think of it like a numbered shopping list where you can cross things off or change apples to pears.
Good analogy. And because lists are so flexible, Python gives you a bunch of built-in functions or methods specifically for working with them.
Okay, what can we do to lists?
The tutorial covers several useful ones. List1.extend list2 takes all the items from list 2 and tacks them onto the end of list 1.
Merging lists.
Kind of, yeah. Append adds just a single item to the very end. Friends.append creed.
Okay.
Insert index, item is more precise. Friends.insert1 Kelly would put Kelly at index 1, shifting everyone else down.
So squeezes in.
Exactly. Then there's removing things. Remove value takes out the first occurrence of that specific value. Friends.remove Jim.
Finds Jim and removes him. What if Jim appears twice?
It only removes the first one it finds.
Yeah.
Clear just empties the list entirely. Poof, gone.
Okay.
Pop is interesting. By itself, friends.pop, it removes and gives you back the last item from the list. Or you can give it an index, friends.tob, to remove and return the item at that specific index.
Okay. Finding stuff.
Index value tells you the index number where that value first appears. Friends.index, Kevin would return 0. It errors if the value isn't there, though.
Good to know.
Count value tells you how many times an item appears in the list. Friends.count, Oscar.
Useful. And rearranging.
Two main ones. Sort arranges the in ascending order alphabetically for strings, numerically for numbers. This modifies the list itself.
So it changes the original list.
Yes. And reverse simply reverses the current order of the elements in the list, also modifying it directly.
Lots of tools for lists. Now, lists are flexible, mutable, but what if you need a sequence that shouldn't change?
That's where tuples come into play. They're introduced next.
How are they different?
Tuples are also ordered sequences like lists, but you define them using parentheses instead of square brackets off, like coordinates equal while.
Okay, parentheses for tuples. What's the big deal?
The critical difference: tuples are immutable. Once you create a tuple, you cannot change its contents. Can't add, can't remove, can't reassign elements.
It's set in stone.
Pretty much, like a final read-only version. You can still access elements using their index, just like lists. Coordinate 0 would give you 4.
But if you tried coordinate 0, 10...
Python would give you an error. A type error, usually. That's immutability in action.
So why use them?
They're often used for collections of data that are conceptually fixed and shouldn't be altered map coordinates, RGB color values, maybe days of the week. Things that just are. They also offer some subtle performance benefits in certain situations, but the main thing is that guarantee of being unchangeable.
Okay, so lists for changeable sequences, tuples for fixed ones. Makes sense.
Lists are definitely used more often day to day, but tuples have their specific important uses.
Right. Now, as programs get bigger, just writing lines of code one after another gets messy.
It gets very messy very quickly and repetitive. You find yourself writing the same block of code multiple times.
So functions are the solution.
Functions are the primary solution for organizing code into reusable chunks. The tutorial introduces them as named blocks of code that perform a specific task. You define it once, then call it whenever you need it.
How do you define one? The def keyword.
Exactly. You use def, then the name you want to give your function, like Sehi, followed by parentheses, and then a colon.
Def Sehi.
Right. And crucially, the code that belongs inside the function must be indented underneath that line. Indentation is how Python knows what code is part of the function.
Indentation matters a lot.
A lot in Python. So you might indent and write print hello user inside the sayHi function.
But just defining it doesn't make it run.
Nope. Defining it is like writing down the recipe. To actually make it happen, you need to call the function later in your code by using its name followed by parentheses.
Sehi.
Okay, define it with def, call it with its name and parentheses.
That's the basic idea.
But functions can be more dynamic, right? They can take in information, parameters. Yes, that makes them much more powerful. You put placeholder names called parameters inside the parentheses when you define the function, like def say hi name. Here, name is a parameter.
A placeholder for a name.
Right. Then, when you call the function, you provide the actual value, called an argument, inside the parentheses. Say hi.
Mike.
So Mike is the argument. Mike is the argument that gets passed into the function. And inside the function, the parameter name will hold the value Mike. So if the function is print, hello plus name, calling say hi Mike will print hello Mike.
And calling say hi Steve would print hello Steve.
Exactly. Same function, different input, different output. You can pass in strings, numbers, even lists or other data types as arguments.
Very flexible. Now, sometimes you don't just want a function to do something, like print. You want it to calculate something and give you back the result, right?
Absolutely. That's the purpose of the return statement.
How does that work?
Inside your function, when you've calculated the value you want to send back, you use return followed by that value. The tutorial uses a cubnum function example.
Okay, def cubnum.
Inside, it might calculate result, num num num, and then have the line return result.
So it sends result back, but where does it go?
It goes back to the exact point in your code where the function was called. But importantly, just calling cube3 by itself doesn't display the result, which is 27. The return value needs to be captured or used.
How do you capture it?
You could store it in a variable. 3 cubed equals cube3. Now, the variable 3 cubed holds the value 27, or you could use it directly. Print cube3. That calls the function, gets the return value 27, and immediately prints it.
Okay, so return sends a value back, but you need to do something with that value.
Exactly. And another key thing about return, as soon as Python executes a return statement inside a function, the function stops immediately. Any code written after the return inside that function won't run.
It's the final answer, basically. Get out.
Pretty much, yeah.
We touched on if statements with the calculator. The tutorial goes deeper into this decision-making.
It does, reinforcing if, else, and elif for controlling which blocks of code execute based on whether conditions are true or false.
They use everyday examples first, right? If I'm hungry, I eat breakfast.
Exactly, to ground the concept. Then they translate it to Python, if condition, followed by an indented block that runs only if the condition evaluates to true.
And else provides the alternative block if the if condition is false.
Right, and elif condition lets you chain multiple checks together. Check condition 1 if false, check condition 2 if false, check condition 3, and so on. Potentially ending with a final else for the none of the above case.
They also bring in logical operators.
Yeah.
And or not.
Yes, to build more complex conditions. If ismail and istall requires both variables to be true, if ismail or istall requires at least one of them to be true.
And not just flips the value. If not, is hungry.
Exactly. Not turns true into false and false into true. These operators let you express much more nuanced logic in your if statements. The tutorial revisits the calculator idea to show how these could enhance it.
Okay, making smarter decisions. Then there's a quick look at another way to store data. Dictionaries.
Right, a very important data structure. Unlike lists, which use numerical indices, 0, 1, 2, dictionaries store information in key-value pairs.
Key-value pair.
Think of a real dictionary. You look up a word, the key, to find its definition, the value. Python dictionaries work similarly. You create them with curly braces.
Okay, curly braces. How do you put stuff in?
Inside the braces, you have key value separated by commas. For example, month conversions, Jan, January, Feb, February, March.
And so Jan is a key and January is its value.
Exactly. And you access the value using the key inside square brackets like month conversions, Jan. That would give you January.
What happens if you ask for a key that isn't there, like month conversions April?
That would cause an error, a key error. To avoid that, the tutorial introduces the .get method.
How's that safer?
Month conversions.get, April, would just return Stella. None, a special Python value meaning nothing if April isn't found instead of crashing. You can even provide a default value. Month conversions.get, April, not a valid key. Now, if April isn't there, it returns that default string instead of none.
.get is more forgiving. Okay, keys and values. Now, for repeating things. Loops. First up, while loops.
Right. While loops are used to execute a block of code repeatedly as long as a specified condition remains true.
As long as the condition is true, keep looping.
Keep looping. The syntax is while condition, followed by the indented block of code to repeat. They show a simple example like printing numbers from 1 up to 10.
But you need something inside the loop to eventually make the condition false, right?
Otherwise, you get an infinite loop. Your program gets stuck running forever. So in the number printing example, you'd have a variable, say I1, the condition while I10. And inside the loop, after printing I, you'd have I plus 1 or I plus 1 to increment it. Eventually, I will become 11. The condition I whole 9 will be false, and the loop will stop.
You need that escape condition. They use this for a guessing game.
Yeah, a simple number or word guessing game. The while loop continues as long as the user's guess is not equal to the secret word and they still have guesses left, using a guess counter and a guess limit. It's a great practical example of while loops.
Okay, loop while a condition holds. What about the other main type of loop? For loops.
For loops are generally used when you want to iterate over each item in a sequence, like going through every element in a list, every character in a string, or a specific range of numbers.
So not based on a condition staying true, but more about processing each item in a collection.
Exactly. The syntax is often like for item in sequence, followed by the indented block, for example, for friend and friends list. And inside the loop, you can print friend.
That would print each friend's name on a new line.
Yep. It automatically goes through each item in friends list, assigns it to the variable friend for that iteration, and executes the indented code.
What about looping a specific number of times?
That's where the range function comes in handy with for loops. For index and range, we'll loop 10 times, with index taking values from 0 up to 9.
Range gives you a sequence of numbers.
Right. You can use range 5, 10 to get numbers from 5 up to 9, or range 0, 10, 2 to count from 0 to 9 in steps of 2, 0, 2, 4, 6, 8. It's very flexible for controlling for loops. You can even combine for loops with if statements inside to do something special for certain items.
You show building an exponent function with a for loop, even though Python has 4 powers.
Yeah, it's a good exercise to understand loops. They create a function raised to a power, basinum, poundum. Inside, it initializes a result to 1, then uses a for loop for index and range, poundum, to multiply the result by the base sum repeatedly, poundum times.
So it builds the power step by step.
Exactly. A practical demonstration of using a for loop for repetition.
They also briefly mention nested loops and 2D lists.
Just a quick intro. Nested loops are loops inside other loops, often used for working with grid-like structures. And a 2D list is basically a list where each element is itself another list, like number grid equals 1, 2, 3, 4, 5, 6. You'd use nested loops to iterate through the rows and columns.
Okay, grids. Now, combining loops and conditionals, they build a translator.
Yeah, a simple giraffe language translator function translate phrase that turns vowels into the letter G.
How does it work?
It iterates through each letter in the input phrase using a for loop. Inside the loop, there's an if statement, if letter dot lower in EUU. It checks if the lowercase version of the letter is one of the vowels.
Ah, using in to check membership. Clever.
If it is a vowel, it appends G to a translation string it's building. If it's not a vowel, the else part, it just appends the original letter. After checking all letters, it returns the final translation string.
And they show adding a check for uppercase vowels, too.
Right, using letter.isupper to decide whether to append a lowercase g or an uppercase g. A nice example of combining iteration and decision-making.
Makes sense. Now, something essential for making code understandable. Comments.
Absolutely crucial, especially when working with others or revisiting your own code later. Comments are notes for humans that Python completely ignores.
How do you make them? The hashtag.
Yep, the hashtag. Anything on a line after #tag is a comment. X equals 5, #tag. This assigns the value 5 to X.
Can you do multi-line comments?
The tutorial suggests just using multiple hashtag symbols, one for each line. Python also has multi-line strings using triple quotes, or which are often used for doc strings, documentation strings at the start of functions or modules. But for general multi-line comments, multiple hashtags are common.
And besides explaining code, you can use comments to temporarily disable code?
Exactly. Commenting out, just put a hashtag at the start of a line or lines of code you want Python to ignore for now without actually deleting them. Very useful for debugging.
Okay, now what happens when things go wrong? Errors.
Errors or exceptions happen. Trying to divide by 0, trying to convert cat to an integer, trying to access a file that doesn't exist. These things can crash your program.
Unless you handle them with try except.
Precisely. The try except block lets you anticipate potential errors and handle them gracefully. You put the code that might cause an error inside the try block.
The risky code goes in try.
Right. And then you have one or more except blocks immediately following it. If an error does occur inside the try block, Python immediately jumps to the matching except block and runs the code there instead of crashing.
So try.result equals 1, 0.
Then except 0 division error.print cannot divide by 0. If that division by 0 happens, it jumps to the accept block and prints the message.
Can you catch different types of errors?
Yes, and you should. It's better to catch specific errors like zero division error or value error rather than just a generic accept, because different errors might need different handling. You can have multiple accept blocks, one for each type of error you anticipate.
Can you get the error message itself?
You can. Using exception as E, the variable E will hold the actual error object, and you can often print to see the specific message Python generated.
Okay, try except for safer code. What about getting data from outside the program? From files?
Yeah, reading from external files is common. You use the open function, giving it the file name, like employees.txt, and a mode. For reading, the mode is R.
File open, employees.txt R.
Right. That gives you a file object. You can then use methods on it, like file.read, to read the entire file content into one big string.
The whole thing at once.
Yep. Or file.readline reads just one line at a time, moving an invisible cursor to the next line each time you call it. File.readlines reads all lines into a list of strings.
What's usually the best way?
Often the most efficient way, especially for large files, is to just loop directly over the file object for line and file.line. That processes it line by line without loading everything into memory at once.
And you need to close the file afterwards, .file.close.
Traditionally, yes. It's important to close the file to release system resources. However, a more modern and safer way is using the with statement with open. Employees.txt R as file.
With open as file.
Yeah. Any code indented under the with statement has access to the file object. The great thing is, when the with block finishes, either normally or due to an error, Python automatically closes the file for you. It's generally preferred now.
Automatic closing. Nice. Can you write to files too?
You can. You use open, again, but with different modes. W is for write mode.
Open index.html.w. What does write mode do?
It opens the file for writing. If the file already exists, W mode will completely overwrite it, deleting anything that was there before. If the file doesn't exist, it creates it.
Overwrites. Be careful with that one.
Definitely. If you want to add to the end of an existing file without deleting its contents, you use append mode A.
Open log.txt A. That just adds on.
Exactly. It opens the file, or creates it if it doesn't exist, and places the cursor at the very end so anything you write gets appended.
And how do you actually write?
You use the .write method on the file object file.write. This is a new line. Remember to include the new line character N if you want subsequent writes to start on a new line.
Okay. Open in R, W, or A, then read or write, and ideally use with for automatic closing.
They're that.
Now, how do we add more tools to Python beyond the built-in stuff in the math module?
That's where modules and libraries really shine. A module is essentially just another Python file, .py file, containing reusable code functions, variables, classes that you can bring into your current script.
Like that usefultools.py example they mentioned.
Exactly. Imagine you create usefultools.py, and inside it, you define a function def roll dice. P. In your main script, app.cli, you can write import useful tools.
Import useful tools.
Then you can access the function using the module name followed by a dot, result usefultools.rolldice10.
So module name dot function name.
Yep. Importing lets you organize your code into logical units and reuse code across different projects without copy pasting.
Where do these modules live?
Well, there are built-in modules that come with Python, like math, random, OS. Then there are modules you write yourself, like usefultools.py, which you typically keep in the same project folder. And then there's a vast ecosystem of external modules written by other people.
External modules. How do you get those?
These are typically installed using pip, the package installer for Python. It's a command line tool. You'd go to your terminal or command prompt and type something like pip install request to install a popular module for making web requests.
Pip install module name.
Right. Pip downloads the module from the Python package index, PyPI, a huge online repository, and installs it into your Python environment yearly in a site packages folder. Then you can just import it in your code like any other module. You can also use pip uninstall module name to remove it.
Okay, pip is the key for external libraries. Now, the tutorial dives into something that sounds fundamental. Object-oriented programming. Classes and objects.
Yes, OOP. It's a major programming paradigm, and Python supports it fully. Think of a class as a blueprint or a template. It defines the structure and behavior for a certain type of thing.
A blueprint for what?
For objects. An object is an actual instance created from that class blueprint. The tutorial uses a student class example. The class student blueprint might define that every student should have a name, a major, and a GPA. These are attributes or data.
So the class defines the idea of a student.
Exactly. It also defines actions a student might perform. These would be methods or functions inside the class. The class usually has a special method called init, 2 underscores before and after init.
The constructor.
Yes, the constructor. It runs automatically when you create a new object from the class. Its job is usually to receive the initial data, like the student's name, major, GPA, and store it in the object's attributes.
How do you create an actual student object then?
You call the class name as if it were a function, passing in the arguments needed by the init method. Student 1, student Jim, business 3.1, student 2, student Pam, art 3.8.
So student 1 and student 2 are now objects, instances of the student class.
Precisely. They are concrete student objects built according to the student blueprint, each holding their own specific data. You can then access their attributes using dot notation. Student1.name would print Jim, print student2.gpa would print 3.8.
Okay, class is the blueprint, object is the actual thing made from it. They use this for a quiz game.
Yeah, as a more practical example, you could have a question class where the blueprint says each question object needs a prompt, the question text, and an answer. Then you can create a list containing several question objects.
A list of questions.
Right, and then a function could loop through that list, presenting each question's prompt to the user, getting their input, and checking it against that question object's answer attribute, keeping score along the way. It organizes the quiz data nicely.
Makes sense, and classes can have functions inside them too, methods.
Yes, that's where the behavior comes in. Methods are functions defined inside a class that objects of that class can perform. The tutorial uses a chef class example.
Okay, class chef. What can a chef do?
The chef class might have methods like def make chicken self,
Yeah.
Brint, the chef makes chicken, and def make salad selflin. Notice the self parameter that's standard for methods, representing the object itself.
So you create a chef object, my chef, chef.
And then you can tell that specific chef object what to do by calling its methods. My chef.make chicken, my chef.make salad.
Okay, objects have data, attributes, and can perform actions, methods. What about inheritance? That sounds complicated.
It's a powerful OOP concept. Inheritance allows you to create a new class, a subclass or derived class, that inherits all the attributes and methods from an existing class, the superclass or base class. It's for creating specialized versions.
Like the Chinese chef example.
Exactly. You
Yeah.
can define class Chinese chef. The parentheses chef indicate that Chinese chef inherits from chef.
So Chinese chef automatically knows how to make chicken and make salad because it inherited those methods from the chef class.
Precisely. You don't have to rewrite them. Code reuse. But the Chinese chef might want to do some things differently or add new things.
Like making fried rice.
Right. You could add a def make fried rice self method just to the Chinese chef class. The regular chef wouldn't know how to do that.
And overriding. Making a special dish differently.
Yes. Let's say the base chef class has a def make special dish self.print. The chef makes BBQ ribs. The Chinese chef subclass can redefine that same method. Def makes special dish self.print. The chef makes orange chicken.
So when you call make special dish on a Chinese chef object, it makes orange chicken. But if you call it on a regular chef object, it makes ribs.
Exactly. The subclass's version overrides the superclass's version for objects of the subclass. It allows for specialization while still inheriting common functionality.
Okay, inheritance lets you build on existing classes. Finally, the tutorial mentions the Python interpreter.
Yeah, just briefly. The interpreter is an interactive mode. You can usually start by just typing Python in your command prompt or terminal. You'll see a prompt.
And you can just type Python code there.
Yep, type print hello, press enter, and it immediately prints hello. Type x equals 5, enter. Type by 2, enter, and it shows 10. You can define functions, call them import modules right there, line by line.
That's a good word.
It's really handy for quick tests, trying out small snippets of code, exploring how a function works, or doing quick calculations without having to create a whole .py file, save it, and run it.
So for quick experiments, not for writing big programs.
Generally, yeah. You typically write larger programs and files using an editor or IDE like PyCharm.
Okay. Wow, that was quite a journey through the basics. So in this deep dive, guided by this excellent beginner tutorial, we've covered a lot of ground.
We really have, from the absolute beginning of setting up.
Yeah, getting Python and PyCharm installed, then the basic syntax, print, understanding that code runs line by line.
Then variables for storing data, the fundamental types like strings and numbers, and how to manipulate them with functions and operators.
And control flow, making decisions with if, elif, else, and repeating code with while and for loops. Super important.
Definitely. Plus, organizing data into collections using lists, changeable, tuples, unchangeable, and dictionaries, key value pairs.
And packaging code into reusable blocks with functions, understanding parameters, arguments, and the return statement.
We also touched on handling errors with try except, reading from and writing to files, extending Python's power with modules and pip.
And even got that first taste of object-oriented programming with classes, objects, methods, and inheritance.
It's a solid foundation based on that tutorial's path.
What's truly valuable, I think, is that this provides you with a robust starting point. By focusing on these core concepts, you now have a much clearer mental mile, of what Python programming is all about.
Absolutely. And hopefully having gone through this makes diving into that tutorial or others like it feel less daunting. You have the context now.
Exactly. Grasping these fundamentals really does unlock the potential to explore more advanced Python topics: web development, data science, automation, game development, so much more.
The possibilities really open up once you have these building blocks in place.
So with this foundational knowledge now swirling in your head, maybe take a moment to think. What problems might you be inspired to solve now? What cool thing might you want to create, or what tedious task in your own life might you be able to automate with a little bit of code?
Yeah, that's the exciting part. What could you build? It really does start here.